when we talk about styling, it's one of the most complex thing ever. It's half of the software engineering is about representing information. And when we use static styling, we kind of hit the road at some point at its end, and at some point you need dynamic styling, where static styling just doesn't work. So what do I mean by data-driven styling? I differentiate two kinds of them. First one is state-based styling. So this can be any data that needs to be reflected in your styling. It could be an API call which results in some data, and you want to reflect it in your UI presentation. It could be a setting, it could be time, it could be anything. So this is where you cannot do static styling because you don't know it as you build the styles. So another kind of data-driven styling is streaming animation. And what I mean by this is, now I have to do demo that way. Let's see if I hit. Can someone see my mouse? No, it's over there. Where's my mouse? Can you see my mouse? Yes. Yeah. So when I swipe this one, you see it now it's swiped. It moves very natural. And the reason for this is it's not just a static animation. It uses a physics engine in order to render this. And this is actually how all the native mobile animations work. They use acceleration data of your pointer, and they generate the real physics data in order to move the objects. This is why they feel so nice and so smooth. And by the way, check this out, this library, Google Material Motion. So if we nice. So if we try to do this on the web, we cannot use transitions or keyframes because they need to know in advance how the animation works, when it starts, when it ends, how it runs, and so on. So we want to achieve this experience, we want an extreme performance on our web platform. We want 60 FPS with JavaScript, each frame controlled by JavaScript in just one thread. This is scary. And this is where you might want to use CSSOM, because CSSOM provides an API no one knows about, and this is basically how it looks like. You create a style element, you insert a rule, and basically you just created real CSS. This is not inline stand, this is real CSS. And the most important thing about it is you can update it. You can update it in the same way you would update inline styles. Basically, you just have this style object and you set the properties, which means we can do any dynamic things you would do with inline styles. So basically, it's a replacement. And in JSS, we have function values interface, which is a high-level interface for the same thing, doing very efficient these updates. Basically, you define a function which returns a value, which is then getting applied to the CSS rule, and this function gets the latest data if you update your component, for instance. So if you want to avoid completely the overhead, React components have, because of their reconciliation, you just use should component update false. And then the entire animation or whatever you update is completely outside of the React update cycle. It's completely performant. So this one is a demo where we render with JSS a bunch of objects. And now I will go until my FPS meter starts showing the dropping frames. How many FPS do we have right now? Let's go to 40 or something. How many objects? 400 objects, 40 FPS. All right. Okay. Let's render the same with inline styles. How many FPS do we have? 4. Yeah. You see, there is an overhead. And if you do animations with inline styles using React, there is a price for that. And we can actually avoid it by simply not using React for animations. And there is another thing. In JSS, we have Observables interface. So basically, Observables is a nice interface if you want to handle pointer events or physics data or any other data streams which are very intensive, and there are a lot of them, so you need some interface in order to describe your animation. If you have an object which has 20 or 100 animation points, animation objects, you some kind of need an interface to describe these animations and synchronize them. So in JSS 9, we have added observable support, which is basically similar to function values, but you can pass an actual observable object, and that's actually it. You can just use any reactive library for this, and it will be rendered, and very efficiently. In fact, it's the most efficient way I found on the web. And observables with CSSOM is actually a great combination because they're both decoupled. Observables are decoupled from the data source and decoupled from the final receiver, which means until events start emitting and a subscriber starts subscribe to event, listen to events, nothing happens with observables. For CSSOM, you can create the style rule, but until you apply the class name or any selector to a DOM node, nothing happens. They are completely decoupled. And they are also completely lazy. So this is nice because it gives us a lot of optimizations. And this is a swinging cat, originally written by David Korshit, and it was originally written using keyframes animation. So this one is written using observables and JSS. And here is the coding challenge for you. Go to this URL, try it out, and try to add events, like DOM events, for instance, mouse move, or whatever else, and try to control the cat. And that's it for me. Thank you.